This begins Part 3 of Chapter 13 from Tillery's Integrated Sciences, and will cover the Trans-Neptunian objects. They can be divided into two categories: the Kuiper belt objects, which are 30 to 55 AUs from the Sun. This includes PLUTO and the Cubewanos. We can also look at the scattered disk objects, which are even farther out from the Sun. They are more than 55 AUs from the Sun, and they have irregular elliptical orbits. PLUTO is smaller than the Moon. It's 70% rock, 30% water ice, tenuous, thin atmosphere, and has an unusual orbit. It's tilted 17 degrees from the ecliptic, and it actually crosses Neptune's. It's about 2,300 kilometers in diameter, and the mass is about 1/4 of the Earth's. PLUTO was reclassified by the International Astronomical Union as a dwarf planet. It is 30 to 49 AUs from the Sun, depending on what time of the year, and it has a 248-year orbital period. PLUTO is composed of a silicate core covered by a water ice mantle. The atmosphere is about 98% nitrogen ice, methane, and carbon monoxide on the surface. PLUTO has 3 satellites: Charon, Nix, and Hydra. Charon is about the same size as PLUTO, and they actually orbit one another. Charon has a synchronous orbit with PLUTO, orbiting each other every 6.3 days. Nix has a 24.9-day orbit around PLUTO, and Hydra has a 38.2-day orbit around PLUTO. The image shown here gives you an idea of the perspective of the Trans-Neptunian objects compared to Saturn, Uranus, and Neptune. You can see several objects that we'll be talking about: PLUTO, Sedna, Eris, and some of the Cubewanos. The Kuiper belt objects are known as the Cubewanos. They are 30 to 55 AUs from the Sun. Several of them are listed here. Makemake is actually the 3rd largest dwarf planet in our solar system. It's about 53 AUs from the Sun and orbits the Sun every 309 years. Quawar is another. Logos, Orcus, Haumea, Varina, and Chaos are a few others. Farther out from the Sun, greater than 55 AUs from the Sun, you have the scattered disk objects. Here is an artist's rendition of one of the scattered disk objects called Eris. It is 97 AUs from the Sun and has a over 500-year orbit. It is the largest dwarf planet that we know of. Its surface temperature is -243 and has a thin atmosphere of methane, ethane, and polymers of those two molecules. It has one moon called Dysnomia, which has a 15-day orbital period around Eris. Sedna is another one of the scattered disk objects. It is 976 AUs from the Sun, and its orbital period, it takes about 12,000 years for this dwarf planet to make its way around the Sun. You can see from these diagrams, just to give you a little bit of perspective on how far out this orbit is. Here's a diagram listing the largest known Trans-Neptunian objects, or TNOs, to give you a size perspective compared to the Earth. You can see several that we've talked about: PLUTO, Eris, Sedna, Makemake, Haumea, Orcus, and Quawar. The rest of our solar system is made up of smaller bodies. In fact, if you were to take all the mass of the solar system, smaller bodies would make up about 2/3 of the total solar system mass. They bombard larger objects like our satellites and our planets, leaving craters as evidence. They are comets, asteroids, and meteorites, and they're left over from solar and planetary formation in our solar system. Asteroids can primarily be found in the orbit between Mars and Jupiter, and they're formed from the solar nebula during planet formation. They're composed of silicate rock materials, carbon-containing materials, metal, iron, and nickel. Meteors are remnants of comets and asteroids. Comets are solid bodies of frozen water, carbon dioxide, ammonia, and methane. It helps to think of comets as a dirty snowball. They have dusty and rocky bits along with the frozen water, ammonia, and methane. The picture shown here is the Hale-Bopp comet, which passed close to Earth in March 29, 1997. You can see from the picture that comets are composed of a comet head, which is a solid nucleus and coma of gas, and a tail. There are two types of tails, ionized gases or dust. The tail usually points away from the sun and is usually visible at night. This picture was taken in the vicinity of Croatia during the Easter holiday, and the tree was illuminated using a small flashlight. If you look to the lower right of the comet, you can see the Andromeda galaxy M31. Asteroids are located between Mars and Jupiter, and they can be up to 1,000 kilometers in diameter. They have a varied composition. The inner belt are mostly stony asteroids. The outer belt is mostly dark with carbon, and others are a mixture of iron and nickel. They're formed from the original solar nebula, and they're prevented from clumping by the gravitational pull of Jupiter nearby. Meteoroids are the remnants of comets and asteroids. They're called meteors when they encounter the Earth's atmosphere and have a tail. Meteors showers are when Earth passes through a comet's tail, leaving debris coming through the atmosphere. A meteorite is when a meteoroid survives to strike the Earth's surface, and there are several types. There are iron, stony meteorites called chondrites or achondrites, or they can be a mixture of stone and iron. Exoplanets are planets that are located beyond our solar system, orbiting a star other than our Sun. And so far, there have been 340 exoplanets discovered. There are a variety of methods listed here that are used to find exoplanets. Here we see an image of what we call the Fomalhaut System. Exoplanets are named in the method of binary stars. If the planet takes the name of the star with a lowercase letter, starting with the lowercase b for the first planet found in the system. For example, the star Gliese 876 is found to have 3 planets. They are indicated as Gliese 876b, Gliese 876c, and Gliese 876d. Most known exoplanets orbit stars in the main sequence of F, G, or K. Here we see the Fomalhaut System, Fomalhaut B planet, and this was first discovered using visible light images. And you can see in the inset there from 2004 to 2006, the reflected light from Fomalhaut B moved. This was proof that there was a planet orbiting this Fomalhaut star. Finally, to wrap this chapter up, you were given a handout which will be 10 points of your short answer section on your test. You should complete this and turn it in by the time of the exam. This is a chart showing what planets would be most likely to give rise to life as we know it. We call this the habitable zone. You can see Earth falls into this habitable zone, and it is in relationship to the size of the sun that the planet orbits and the distance from that sun. And Earth falls perfectly in the middle of what we call this habitable zone. Mars falls slightly outside of that zone, but many people believe Mars was once inside this habitable zone when the sun was much younger and hotter. I hope you've enjoyed these photo stories for Chapter 13, and you may review them as many times as you wish. Use the learning objectives to help you study for your exam.